picture an early human, a caveman. What do you see? Probably a stocky figure, hunched over, maybe holding a club. And covered in hair, a lot of hair. Like a shaggy carpet from head to toe. It's an image we've seen in movies, in cartoons, in museum displays. The brutish, fur-covered ancestor. It's a powerful image. But is it right? Were our ancient relatives really that hairy? The short answer is, for a very long time, yes. And then for a very long time, no. The story of human hair is not one of a single, static image. It's a story of loss. It's a story about becoming the strange, naked ape we are today. And the reasons for that transformation are tied to the very things that made us human in the first place. It's a story about heat, sweat, and survival on the open plains. To understand why we lost our hair, we first have to understand why we had it. Our closest living relatives, chimpanzees and gorillas, are covered in it. So were our more distant shared ancestors. Fur, or a thick coat of hair, is incredibly useful for a mammal. It's a fantastic insulator, keeping you warm in the cold, and to some extent, protecting your skin from the direct heat of the sun. It protects the skin from scratches, from insect bites, and from rain. It can provide camouflage, helping an animal blend into its surroundings. It's a default setting for primates. For millions of years, our ancestors lived in forests. They were apes, living in a world of dappled sunlight and shade. A coat of fur made perfect sense. It was the best tool for the job, but then the world changed, and our ancestors changed with it. Around 2 or 3 million years ago, the climate in Africa became drier. The vast, dense forests began to shrink. In their place, the savanna expanded. The savanna is a different world. It's a world of open grasslands, scattered trees, and relentless direct sun. Our ancestors, a group of early humans we call hominins, came down from the trees. They started spending more and more time on the ground, walking upright on 2 legs. This new environment presented a huge problem. That problem was heat. A fur coat is an insulator. That means it's good at trapping heat. In a cool, shady forest, that's not a big issue. But out on the savanna, under the equatorial sun, it's a death sentence. An active animal running around in a fur coat in that heat would quickly overheat. Its brain, the most temperature-sensitive organ in the body, would cook. Survival on the savanna demanded a new way to deal with heat. Our ancestors evolved a radical solution. They became the sweatiest primates on the planet. The humans have a superpower that other apes don't. We have millions of tiny sweat glands, called eccrine glands, all over our bodies. When we get hot, these glands pump out a watery liquid. As this sweat evaporates from our skin, it takes heat with it. It's an incredibly effective cooling system. It's like having a built-in air conditioner. But there's a catch. This system only works well on bare skin. Try to imagine sweating with a full coat of fur. The sweat would just get trapped in the hair. It would mat it down, making it a soggy, useless mess. Evaporation would be slow and inefficient. The fur would stop the cooling system from working. So, for our superpower of sweating to work, the fur had to go. This change wasn't just about walking around in the sun. It was about running in the sun. As our ancestors moved into the savanna, their diet changed. They started eating more meat. Meat is a concentrated source of calories and protein, essential for fueling a large, energy-hungry brain. But getting meat isn't easy. Early humans weren't the strongest or fastest predators. They couldn't outrun an antelope in a short sprint. They didn't have massive claws or sharp teeth. They had to use their brains, and they had to use their endurance. This led to a hunting strategy called persistence hunting. It's one of the most incredible feats of human biology. The idea is simple. You pick an animal, say a kudu or a wildebeest, and you just keep chasing it. The animal is a sprinter. It will bolt away at high speed. You just jog after it, keeping it in sight. The animal will stop to rest, thinking it's safe. But then you show up again. It sprints away again. You jog after it again. You do this over and over for hours in the heat of the day. Here's the brilliant part. That kudu is a sprinter, but it can't cool itself down efficiently. It's wearing a fur coat, and it cools down by panting. Panting is not very effective when you're also trying to run at full gallop. So, after a few sprints in the midday heat, the animal starts to overheat. It gets exhausted. It eventually collapses from hyperthermia, and the human hunter, jogging along, cooled by a constant film of evaporating sweat on naked skin, simply walks up and finishes the job. And persistence hunting would have been impossible for a hairy hominin. They would have cooked their own brain long before the prey did. Losing our body hair was a critical trade-off. We gave up the insulation and protection of fur. In return, we got the ability to run for miles in the heat. We became the marathon runners of the animal kingdom. This ability to regulate our temperature gave us access to a huge new food source, which, in turn, allowed our brains to grow. Being naked wasn't a weakness, it was a weapon. So, when did this happen? We don't have fossilized skin or hair from our ancestors like Homo erectus, but we have clues. Lots of them. The first set of clues comes from the skeleton. Around 1.9 million years ago, a new kind of hominin appears in the fossil record, Homo erectus. Compared to its ancestors, like the famous Lucy Australopithecus afarensis, Homo erectus looked much more like us. It had long legs, shorter arms, an arched foot, and other features that made it an excellent long-distance runner. Its body was built for endurance. This is strong indirect evidence that it was living a lifestyle where overheating was a major issue, a lifestyle that would have strongly favored hairlessness. The second line of evidence is genetic. We can't get DNA from Homo erectus, but we can compare our own DNA to that of our primate relatives. One of the most important genes in this story is called MC1R. This gene plays a big role in controlling the production of melanin, the pigment that gives our skin and hair its color. When our ancestors lost their body hair, their skin was suddenly exposed to the intense ultraviolet UV radiation of the African sun. The UV radiation can damage DNA and cause skin cancer. It can also break down a vital nutrient called folate, which is crucial for healthy fetal development. To protect against this, our skin evolved to become dark. Dark skin is rich in melanin, which acts as a natural sunblock, absorbing and scattering harmful UV rays. By looking at the diversity of the MC1R gene in modern African populations, scientists can estimate when strong evolutionary pressure for dark skin first emerged. The data suggests this happened around 1.2 to 1.5 million years ago. This gives us a rough timeline. If our ancestors were evolving dark skin to protect them from the sun, it's a very strong indicator that they had already lost their protective coat of fur. You don't need sunblock if you're wearing a fur coat. The evolution of dark skin and the loss of body hair almost certainly happened together. There's another stranger piece of evidence, and it comes from lice. Humans are unique in that we can be hosts to two different kinds of lice, head lice and pubic lice. Head lice live on our heads. Pubic lice, often called crabs, live in our pubic region. Genetically, they are distinct species. What's fascinating is where pubic lice came from. Genetic analysis shows that the human pubic louse is most closely related to the louse that lives on gorillas. This tells a bizarre and compelling story. At some point, our ancestors had a single coat of hair and presumably a single species of louse that lived all over their bodies. Then we lost most of that body hair. This created a vast, hairless desert between the forest of hair on our heads and the smaller patch of hair in our pubic region. The original louse population was split in two. The lice on the head were isolated from the lice in the groin. They couldn't cross the barren landscape of the torso. Over time, these two isolated populations evolved into separate species. The head louse became the head louse we know today. So where did the pubic louse come from? The best theory is that we picked it up from gorillas, not through fighting or hunting, but likely from sleeping in places where gorillas had recently slept, or through some other form of close, non-hostile contact. A gorilla louse found a new, unoccupied habitat on our bodies that was similar to its old one-course, thick hair. And it stayed. By using a molecular clock to measure the genetic differences between human pubic lice and gorilla lice, scientists can estimate when they split from their common ancestor. The timing points to somewhere around 3 million years ago. This suggests that by this time, our ancestors had already lost enough body hair to create that naked desert and provide an empty niche for a new type of louse to colonize. While the dates from different lines of evidence don't match up perfectly, they all point to the same general story. The loss of body hair was a gradual process that was well underway by the time of Homo erectus, perhaps even earlier. So the image of a hairy Homo erectus is probably wrong. They were likely much more like us, naked, dark-skinned, and sweaty. But the story doesn't end there. We didn't lose all our hair, we kept some in very specific places. And the reasons we kept it are just as interesting as the reasons we lost the rest. Let's start at the top. The hair on our heads. Why keep a thick mop on top when we got rid of it everywhere else? Again, it's all about the sun and the brain. The human brain is a massive, delicate, and metabolically expensive organ. It's also extremely sensitive to temperature changes. While our sweating system is great for cooling the body, the head gets the most direct, intense exposure to the sun, especially in the middle of the day in equatorial Africa. A thick mat of hair on the head acts as a fantastic shield. It absorbs and reflects solar radiation, keeping the heat from penetrating directly to the skull and cooking the brain. It creates a layer of trapped air that acts as insulation, slowing down heat transfer. In a way, we evolved a built-in hat. This head hair would also have been useful for retaining heat during cool nights. Then there's the hair in our armpits and pubic region. This hair is different from the hair on our head. It's coarser and it only appears at puberty. The most common explanation is that it's for signaling and scent. These areas are dense with apocrine glands, which produce a thicker, oilier sweat than the eccrine glands. This sweat contains chemical compounds that are broken down by bacteria on our skin, producing body odor. The thick hair in these regions is perfect for trapping and wafting these scents, which contain pheromones. Pheromones are chemical signals that can convey information about an individual's health, genetic fitness, and readiness to mate. The appearance of this hair at puberty also serves as a clear visual signal of sexual maturity. Another, more practical reason is that this hair reduces friction. The skin in our armpits and groin rubs together constantly when we walk or run. A patch of hair can act as a dry lubricant, preventing chafing and irritation. And what about our faces, eyebrows, and eyelashes? They seem minor, but they serve critical functions. Eyelashes are like tiny fences for our eyes, catching dust, sweat, and other debris before it can cause irritation or infection. The eyebrows are even more interesting. They are perfectly shaped to channel sweat and rain away from our eyes, diverting it to the sides of our face so we can keep our vision clear. This would have been incredibly important for a hunter trying to track prey or a forager looking for food. But eyebrows do more than that. They are one of the most important tools for non-verbal communication. We use them to express surprise, anger, sadness, and curiosity. They are central to how we recognize faces and read the emotions of others. The subtle movements of our eyebrows convey a huge amount of social information. So the story of human hair is one of refinement. We didn't just shed our fur coat. We sculpted our hairlessness. We got rid of it where it caused us to overheat, but we kept it, and even specialized it, in places where it gave us an advantage. We kept it to protect our brains, to send sexual signals, and to communicate with each other. This leads us to the Neanderthals, those famous cavemen who lived in Europe and Asia. They were our close cousins, not our direct ancestors. They lived in much colder climates than the African savanna. So, were they hairy? It's a reasonable assumption. In a cold environment, a thick coat of hair would be a great advantage for insulation. But the evidence is tricky. We have some genetic data from Neanderthals. Analysis of their MC1R gene, the same one involved in skin pigmentation, suggests that at least some Neanderthals had pale skin and red hair. This makes sense. In the less intense sunlight of northern latitudes, dark skin is a disadvantage because it makes it harder to produce vitamin D, but this gene only tells us about hair color, not hair density. The best guess is that they were probably hairier than modern humans, but not covered in a thick ape-like fur. They knew how to make clothes from animal hides. They knew how to control fire. They had cultural and technological solutions to the cold. They likely had more body hair than us, perhaps a fine layer of downy hair, or just a greater density of the hair we still have. But the classic image of a Neanderthal looking like a shaggy beast is probably an exaggeration. They were hunters who needed to be active, and even in the cold, a full fur coat can lead to overheating and dangerous sweating during exertion. A wet fur coat in an ice age is a death warrant. It's more likely they used their intelligence to solve the problem of cold, with clothing and fire, rather than relying solely on a biological fur coat they may have lost long before their ancestors ever left Africa. And what about us, modern humans? Our relationship with our body hair is now almost entirely cultural. We have inherited the biology of a savanna persistence hunter, a biology that is now somewhat out of place in our world of air-conditioned offices and cars. The functional reasons for having or not having hair have been mostly replaced by social and aesthetic ones. We shave, wax, pluck, and style the hair we have. We use it to signal our identity, our beliefs, our age, and our status. A full beard might signal masculinity in one culture, while a clean-shaven face is the norm in another. Long hair on a woman might be a sign of beauty, while a shaved head can be a symbol of rebellion or piety. We have taken the biological canvas we inherited and turned it into a medium for art and expression. So when we look back at our ancient ancestors, we shouldn't picture a simple, furry beast. We should picture a creature in transition, a creature losing its past to adapt to a new future. So we should see the early hominins in the forest covered in hair like their ape cousins. Then we should see their descendants, like Homo erectus, emerging onto the hot savanna, their bodies sleek, dark, and mostly bare, glistening with the sweat that allowed them to outrun their prey and fuel their growing brains. We should see our Neanderthal cousins, adapted to the cold, probably a bit hairier than us, but masters of fire and clothing. Our nakedness is not a sign of frailty. It is a sign of our unique evolutionary journey. It's a testament to our endurance. It is a story written on our skin. We are the ape that gave up its fur coat for our cooling system. We traded the passive protection of hair for the active advantage of sweat. And that trade-off, that strange and radical adaptation, was one of the key steps that allowed a group of African primates to spread out and eventually inhabit every corner of the globe. The next time you look in the mirror, don't just see a person. See a survivor of the savannah. See the result of millions of years of heat, of running, and of a profound and successful evolutionary gamble. The hairless ape is a strange creature, but its lack of hair is central to what makes it human.